going to be looking at today is simplifying rationals. All right, the first step in simplifying any rational is you have to check for factoring. So, starting off with example 1. Going from x cubed plus x squared over x plus 1. Oh, what can I pull out of the top? Again, we're checking for factoring. So I can pull out an x squared. Then you're left with x plus 1. What do I have on bottom? X plus 1. Oh, well, they're the same. So my x plus 1s and my x plus 1s can cancel, simply because they are multiplied by that x squared. Let's look at example 2. Okay, I have x squared plus 6x plus 5 over x squared minus 25. Again, can I factor the top? Well, factors of 5 that add to 6, yeah, 5 and 1. So it factors to x plus 1, x plus 5. Bottom, what type of factoring is that? Oh, that's dots. So I have x plus 5, x minus 5. What can I cancel? Again, my x plus 5s, because there's multiplication here. All right, you must, in order to do the canceling trick, if you will, it must be multiplied by another factor. If it's added to another type of factor, you cannot do that. Okay. Next, we're going to get into multiplying rationals. Okay. In multiplying rationals, we have to simplify anyway, and I just plain out, I want you practicing this. So, multiplying rationals. First thing we must do, we must simplify. And then multiply like regular fractions. Multiply your numerator, multiply your denominator. Your numerator and your denominator. Okay, so for example 3. X squared plus 5x plus 6 over x squared plus x minus 6 multiplied by x squared minus 9 and then x squared minus x minus 6. Well, again, the first step I told you was simplify. So the first thing we do in simplifying is we're going to check for factoring. Can I factor the top? Well, factors of 6 that add to 5, isn't that 2 and 3? So that factors to x plus 2 and x plus 3. Then here, factors of negative 6 that add to 1. Well, that would be negative 2 and positive 3. So x minus 2 and x plus 3. Here I'm multiplying x plus 3, x minus 3, or factors of negative 6, negative 3 and positive 2. And x x plus 2. Well, let's see what that cancels just from my fractions. Well, my x plus 3 and my x plus 3. My x minus 3 and my x minus 3. Now let's multiply across the top. So x plus 2, x plus 3. I'm multiplying just my numerators and my denominators. X minus 2, stick a fraction bar in there, and x plus 2. Again, what cancels? My x plus 2 and my x plus 2. I am left with x plus 3 for x minus 2. Alright, now we're going to get into dividing denominators. Okay, they are exactly the same as multiplying. You just flip and multiply. So, let's start here. Alright, call it dividing. First thing you're going to do when you're going to divide rationals is you're going to flip, then multiply. I know you were taught that in the 7th or the 8th grade. And then, or leave it the same, change it and rearrange. Flip, then multiply. So, example 4. Alright, we're going to do x squared minus 4 over x squared plus 3x minus 10. We're going to divide it by x squared plus 5x plus 6 over x squared plus 8x plus 15. First thing I said, you flip then multiply. So we leave this the same. Alright, we leave my first fraction the same. Same, change, rearrange. So leave my first fraction the same, x squared minus 4 over x squared plus 3x minus 10. Change division to multiply. And then flip my last fraction. So it becomes x squared plus 8x plus 15 over x squared plus 5x plus 6. Now, I start factoring. Well, x squared minus 4, how can I factor that? Factor that using dots. X plus 2, x minus 2. Using dots or a difference of 2 squares. Now let's look at the last one. Factors of negative 10 that add to 3. Alright, well, positive 5 and 2, right? Or negative 2. So x plus 5 and x minus 2. Does that add to 3? Yes, it does. Now we're multiplying. Alright, factors of 15 that add to 8, 3 and 5. So x plus 3, x plus 5. Factors of 6 that add to 5, 2 and 3. So x plus 2 and x plus 3. Let's see what cancels. Well, my x plus 3 is on this side. My x minus 2's. Now let's just multiply straight across. So I have x plus 2 times x plus 5 over x plus 5 over x plus 2. Now let's see what cancels. My x plus 2's cancel. So do my x plus 5's. What do you think that's going to leave me with? Well, x plus 2 times x plus 5 and x plus 5 times x plus 2, those are literally the same thing, commutative property. So anything divided by itself is always and forever 1. A lot of people try to tell me this is 0. This is not 0. That is 1. That's a rarity, but it's just one I thought I would show you. Now, let's look at complex rationals. And all we're doing with our complex rationals is we're simplifying them. Okay. So, Okay, example 5. We have 1 plus 1 over x, all divided by 1 minus 1 over x. Okay, my whole goal is get rid of my fractions. So what is a denominator here I want to get rid of? Well, x. So here's what I'm going to do. I'm going to multiply everything by x. Okay, so I am left with x times 1, which is x. All right, 1 over x times x is just 1, so x plus 1. Then here, next one, x times 1 is x, minus, well, 1 over x times x, we already agreed is just 1. I'm simplified. Looked like it had a lot of fractions. Looked really scary. Wasn't really that bad, was it? Okay. Last example, more complex fractions. All right, I have all right, 3 over x minus 2 minus 4 over x plus 2 all over 7 over x squared minus 4. Well, to make my life easier, I know I can factor out x squared minus 4. So let's do that first before we try to do anything else. 3 over x minus 2 minus 4 over x plus 2 over, all over, 7 over x plus 2, x minus 2. Okay, first thing I want to do, which denominator do you want to get rid of first? Well, let's go with x minus 2. So we're going to multiply every piece by x minus 2. X minus 2 times x minus 2 times x minus 2. Well, here, my x minus 2 is canceled, and I am left with just a 3. Here, nothing cancels, so I have minus 4 times x minus 2 all over x plus 2. Then, x minus 2's cancel those, and I am left with 7 over x plus 2. Okay, what other denominator do I want to get rid of? Well, let's get rid of x plus 2. So I'm going to multiply everything by x plus 2. X plus 2 times x plus 2 times x plus 2. Okay. Cancel out my x plus 2's here. My x plus 2's cancel. I no longer have denominators anymore. All I'm going to have left with is 3 times x plus 2 minus 4 times x minus 2 all over 7. Then it's just distribute and simplify. Okay, 3x plus 6 minus 4x plus 8 all over 7. Combine like terms. Negative x plus 14 over 7. I can also, something you may see, another way you need to know to write this is negative x over 7 plus 2, or even negative 1 over 7 times x plus 2. All three of those are the same. Okay, you need to recognize those.